Welcome back to Kamal Kunj Home Academy, Encounter with Mathematics. In this session, we will discuss about hyperbola and the related terms. What is hyperbola? Hyperbola is the set of all points in a plane the difference of whose distances from fixed points in the plane is a constant. Hyperbola is the set of all points in a plane, the difference of whose distances from two fixed points is a constant. Now the two fixed points are called foci of hyperbola. The two fixed points are called foci of the hyperbola. What is center of hyperbola? Center of hyperbola. The midpoint of line segment joining foci is called center of the hyperbola. Is transverse axis of hyperbola. Transverse axis of hyperbola. A line joining to Foci, the line joining to Foci is called transverse axis. Transverse axis of hyperbola. Now let x dash of x and y of y dash be the coordinate axis. Now if the origin is taken as center of the hyperbola, then axes are along x and y axis. This is the x axis. And this is y o y dash. These are the coordinate axes. This is A and B. This is transverse axis. And there is conjugate axis. What is conjugate axis? Line passing through the center and perpendicular to the transverse axis. Transverse axis is called conjugate axis. So if origin is taken as center, then x transverse axis is along x-axis and conjugate axis is along y-axis. Now the length of transverse axis is here. AB is the transverse axis. Its length is equal to length of transverse axis is twice A. That is AB equal to twice A. So this will be A and this will be A. OA equal to A and OB is equal to A. Now, Foci are here F1 and F2. Distance between Foci is twice C. Length of conjugate axis is twice B, where B is equal to B is defined as C square minus A square. Distance between Foci, that is F1, F2, is equal to twice C. Now, how to find the value of this constant? This is the difference between distance of this any point on the hyperbola from the foci. Suppose a point, any arbitrary point P xy on the hyperbola. So this constant is difference between Pf1 and Pf2. Now suppose there is a point here A and at B, a point P. If point is at this point B, then suppose there is let point P is at B, then BF1 minus BF2, there is the difference between point from to Foci. Minus BF2. Now when point is at A, difference from Foci will be when point P is at A, then difference will be AF2 minus AF1. So distance of this point from here and from here. So these two differences, and by definition of hyperbola, should be equal. By definition of hyperbola, BF1 minus BF2 should be equal to AF2 minus AF1. What is BF1? BA plus AF1. So this implies that BF1 is BA plus AF1 equal to, what is AF2? AB plus BF2. AB plus BF2 minus AF1. Here, sorry, minus BF2. So this gets cancelled. This implies that twice AF1 will be equal to twice BF2. This implies that AF1 should be equal to BF2. That is, AF1 will be equal to BF2. Now BF1 minus BF2 will be equal to BA plus AF1 minus BF2. This is equal to BA, since F1 is equal to BF2. And BA is twice A. So this is equal to twice A. So difference between the distances of the point from the two foci is equal to twice A, which is a constant. Now what is eccentricity? Eccentricity of a hyperbola is E equal to ratio C upon A. Now since value of C is greater than A, C is OF1, A is OS, so value of C is greater than A. This implies that C upon A, this ratio will be greater than 1. So this is called eccentricity of a hyperbola. Now we will stop here and continue further in the next session. Till then, goodbye and thanks for watching.